So in our last part 3 of section 4.4, we're going to tackle 2 more problems. One of them is the rain gutter problem. So example 5 reads, a rain gutter is to be made of an aluminum sheets that are 10 inches wide by turning up the edges 90 degrees. So these sheets are long, but they're only 10 inches wide. What depth will provide the maximum cross-sectional area and hence allow the most water to flow? Okay, what does that mean? Okay, so what we're going to do is we're going to look at the sheet head on or dead on from the end. So it's extending into the board. We know that this is 10 inches long, okay, and then it goes into the board. What we want to do is we're going to bend it and fold sides up. So we're basically going to fold this up and this up to make a U shape. And that U shape basically is a rectangle that's open on the top, right? You don't need the top, but it extends into the board. So if we can make this have the most area, then it will hold the most volume, which is great, which is what we're after. So the question is asking, how much are we going to fold up? So we're going to fold up X on this side and X on this side. That'll be our variable. So we're looking at X right here. So what we need is area. So that would be length and width again. Same problems we had before. We're calling the width X. So we know we have an X sitting down there. But what's this dimension? Well, we started off with 10. We took out X on this side and we took out X on this side by folding it up. So then this dimension is 10 minus 2X. So our length is 10 minus 2X. So we didn't have to write a whole separate equation this time because they gave me something about the overall piece of metal to start from. So that worked out much nicer. And now this is an area in terms of X. Let's go ahead and distribute that in. That's going to be a negative 2X squared plus 2X. We'll go do our analysis again to get a handle on what the numbers are. So when we go to graph this, again, it's a parabola opening down. I do apologize. Pretty much all the examples in the books are maximums. It's hard to do minimums at this level, but you could do a minimum cost function. You could do a minimum surface area function. So there are minimums out there. Your book just likes the maximums, apparently. Okay, what do we got? Well, the horizontal axis is our input, which is X. And in this case, this is going to be the depth of the rain gutter. The output, our vertical axis, is the area. Now, what they're asking us to find is just the depth. They're not asking for the actual area. So I need to be careful when I'm doing my negative b over 2a and make sure I'm giving back the correct answer. So negative b over 2a, that would be a negative 10 all over 2 times negative 2. That would be 10 divided by 4, which is 2.5 inches. And we know that that 2.5 is the X coordinate of the maximum, and that is the depth. So this is the answer. So we're going to both fold up 2.5 inches on either side. And we've already got our answer. This actually is the same kind of problem or flavor to it as that farmer and the fence problem. So it should flow nicely after having done 3 of those farmer kind of problems. So, and then finally, our last example is taken from the business world. Okay, this is example 6. A convenience store owner sells 20-ounce soft drinks for $1.50 each and sells an average of 500 per week. Using a market survey, she believes that for each 5-cent decrease in price, so if I drop the price, I'm going to sell an additional 25 soft drinks. What price should we charge to maximize the revenue, and what is the maximum revenue? So in other words, there becomes a point where dropping it no longer sells as many of them. I know that seems weird, but you'll see it in the quadratic function. So well, we need to figure out what revenue is. So in words, which I think is really important on this problem, that revenue is made up of 2 things. So it's made up of the number of drinks we sell times the price per drink. Hopefully that makes sense. So how much you sell them for times how many you sell is going to be your revenue. Well, we know that in the beginning, we sell 500 drinks. We also know in the beginning that the price is $1.50. But we want to do some wiggling here and see if we can get more money out of this. So what we're going to use, we know that, what are we going to do? We're going to decrease the price. So I'm going to minus 0.05. And if I do that, I increase the number I'm selling by 25. So I could do it one time and see what happens. But maybe I want to do it more than once. Maybe once is not enough to give me a maximum. So what we're going to do is we're going to put an X in as our variable. Now, X over here is really what I'm going to call a count of the increase or decrease. So it is a counter or an increment. It's got nothing to do with the price. It's got nothing to do with, sorry, it does have something to do with the price, but when you're all done, it won't give me the price, right? So we're going to put an X by the 25, and we're going to put an X over here by the 0.05. Again, that's just telling me, am I going to increase the number of drinks sold by just 1 or by 2 or by 3 or what? So am I going to drop the price by just a nickel or a second nickel or a third nickel? Okay, so there's our equation. Doesn't look very good right now. We're going to go ahead and FOIL that out. So we need 500 times the 1.5. That gives me 750. 500 times the 0.05 is a negative 25x. 25x times 1.5 is going to give me a positive 37.5x. And 25 times the negative 0.05 is going to give me a negative 1.25x squared. Let's collect like terms and put that in descending order. So negative 1.25x squared plus 12.5x plus 750. And there's our quadratic equation. Again, notice it's negative, so it's opening down. So when we look at a quickie graph of this thing, x is the input value, and in this case, it's the count. It's how many increases or decreases we're going to do. The output is our revenue. So this is our revenue bar. It's opening down. So again, it has a maximum. And we know by now, after several examples, to find that maximum, we're going to go do negative b over 2a. So negative b over 2a would be negative 12.5 all over 2 times a negative 1.25. And that comes out to be 5. Well, that was nice. But again, remember, this is our count. So this is the number of times we are going to drop the price by a nickel. So we're going to drop the price by a nickel every single time 5 times. So to get the price, I'm going to go back to this because we know that the price is 1.50, the original price, minus a nickel times 5 different price decreases. So this 5 is coming into play right here. And if we do that, we end up with what? That's a quarter, so it's $1.25. So we're going to sell these drinks for $1.25. And if we do that, what do we get as a revenue? So the revenue, we're going to take this 5 and plug it back into R. So we are finding R of 5. So negative 1.25 times the 5 squared plus 12.5 times my 5 plus 700. And if you do that, you'll find out that your revenue is $781.25. Now I could have elected, and it might have been easier, I think it's easier, to plug the 5 into this, because that would have given me 625. So the number of drinks sold, number of drinks would be the 500 plus 25 times 5. If you do that, you get 625 drinks. And in my brain, it's a lot easier to take 625 drinks and multiply it by $1.25 than it is to plug into that quadratic function. It's your choice. So here's our maximum revenue, and here's how much we're going to charge. I hope you have fun with that.